Hey guys, Mr. Ritz here to help you out on section 3.5 here. We're going to be solving by completing the square. So this is another way that we can solve quadratics. And it kind of goes a special route here. All right, so what we want to do here is pause the video, see if you guys can factor these problems here. Okay, let's check our answers here. All right, so if you notice, everything special about one of these problems here is that they are all basically the same factor twice here. So what two numbers multiply together to give you one, add together to get two, that's 1 and 1. And we would write x plus 1 times x plus 1 or x plus 1 squared. Same thing here, we'd get, we would get 6 times 6 or negative 6 times negative 6 to get the negative 12, x minus 6, x minus 6. 9 times 9, 9 plus 9 is 18. Negative 11 times negative 11. Here we go. Now, if we notice these numbers here, these numbers in the middle are always, we can cut them in half and square them to get the middle number. So notice there, if I take the 2, cut it in half, square it, I get 1. 6 cut in, or 12 cut in half is 6 or negative 6. If I square negative 6, it's still positive 36. All of these end with a plus. Doesn't matter what the symbol in the middle, but we can cut it in half and square it, except for this last term here, because we have the number in the front. All right. So what we're going to be looking at today is, can we solve properties using the square root? And then once we get that, we're going to complete the square. Okay, so when we solve properties by using the square root, what we can do is we can get the x by itself, but then we just have to remember here that whenever we take the square root of something, now technically we get a positive and a negative version of that. So if I want to solve this expression here, I can add the 49 over, and then when I take the square root, we have to remember we have positive and negative. Because if I were to factor this expression here, I would have an x plus 7 and an x minus 7, and that shows that we have two solutions. One's positive and one's negative. So we can use square roots as long as we go through. Now, sometimes we get some more complex numbers here. We have to remember that those solutions have to be in that radical form, okay? A plus bi or a plus something radical c. Okay, so what we're going to do is to solve this by completing the square. All right, so when we look at this problem here first, we're going to check to see, do we have a perfect square? So to check to see if a perfect square, we have to see, if we take this middle number, cut it in half, and square it, does it equal that number? And if it does, we can write it as a perfect square. All right, so we got this problem here, so we can factor this because 4 cut in half is 2, 2 squared is 4. So what we can do is we can write this as a or x minus 2 squared, because the square root of 4 is 2. We're going to keep the minus sign in the middle as the same. Basically, we just cut this middle term in half and we write it here. And then equals 25. Now, if I want to solve this, if I want to get the x by itself, I can take the square root to get rid of the square. We have to remember anytime we take the square root, we get the positive and the negative version. So we basically get two answers here. X minus 2 equals plus or minus 5. And so what we get is we're going to split this up into x minus 2 equals a positive 5, and another problem of x minus 2 equals a negative 5. And when we add 2 to both sides, I would get x equals 7. And if I was to add 2 on this side, we get x equals negative 3. Okay. So this is just another way algebraically we can figure this out. Now we could have subtracted that 25 over, set equal to 0, and factored that problem. Let's just show you guys another solution, another way that we can do this. All right, so pause this video. Let's see if you guys can do this one as well. All right, so we double check, does negative 38 divided by 2 squared, does that equal 361? Let's see, 19 squared. Yep, is 361. So we would get a x minus 19 squared is equal to 576. All right, so that means x minus 19 equals plus or minus the square root of 576. All right, so x minus 19 equals plus or minus, what is the square root of 576? 576. Square root 576. That's 24. So we get an x minus 19 equals 24. And x minus 19 equals negative 24. Finding our two problems here, our two solutions. If I add 19 over to 24, that would be a 43. If I add 19 over to a negative 24, that would be a negative 5. There's our two problems here, two solutions. Yay, I did right. Okay, next, let's check this other one. How do we do it when it doesn't come out so nice? Okay, if I take 24, cut it in half, and square it, does it equal 144? All right, it does. All right, so we get x plus 12. Notice it's a plus sign because that's a plus in the middle. So it's going to be a plus in the middle here, equals 192. So x plus 12 is equal to, alrighty, what's the square root of 192? It's decimals. So this is how we can get, if you guys remember when we went over graphing, sometimes we get problems that are decimals that we can't figure out. This is actually how we can find those exact answers. We still want to break down the 192. So off to the side, 192, we're going to break it down. Okay, that is 2 and 96. That's 2 and 48. That's 2 and 24. I'm just going to 2 and 12. Let's keep doing a bunch of twos. 2 and 6, 2 and 3. Let's see it. A set of twos, a set of twos, another set of twos. So 2 times 2 times 2. So that gives us 8. All right. We get 8, radical 3. The 3 is left over on the inside. Now, since this is a radical, that is not a radical. They cannot add or subtract together. So our answer, we're going to write it as kind of a more complicated answer, but we would minus the 12 over, and we're going to say it's negative 12 plus or minus 8 radical 3. That is good enough because that tells us one answer is negative 12 plus 8 radical 3, which is some number. And then we'd also have another number of negative 12 minus 8 radical 3, which is another. But since these are kind of complex answers, we have a regular integer and then a radical expression added and subtracted together. We can just make our life easier and say, hey, here's the plus or minus sign. There's our two answers. All righty. So, yep, that's what I just said. There's our two answers. And then decimal approximations. That's what we would have found roughly on Desmos, but our exact answers are there. So why don't you guys give this one a try here? Oh, okay, no, let's actually, not this one. What we got going on here, if you notice, we have this 2 in front. So what we're going to do first is we're going to divide everything by 2. Divide everything by 2. So we get a x squared minus, that'd be what? 46 x plus, what's 1058 divided by 2? 529 equals negative 36. Okay, double check. If I take 46, cut it in half, and square it, do I get 529? So 23 squared is 529. Okay, cool. Everything's working out good. So we get x minus 23 squared equals negative 36. We take the square root of negative 36. And 36 is nice, but negative 36 is going to be a 6i. We get imaginary values. So here's another example how we can have a complex solution, a complex root that's imaginary. Got the plus minus. So just like when we had the radicals, the 23 is an integer. This is imaginary. So we're just going to put it in front. We would add it over. So it would be a positive 23 plus or minus 6i. So our two answers are technically 23 plus 6i and 23 minus 6i. That's a good enough answer right there. Okay. So not all equations are set up where we can have a perfect square like we did before. So what we can do is go through a process called completing the square to kind of make a perfect square. Okay, so what we're going to do is have this blank here, and they call it the square because we're going to figure out, and I'm going to draw a box there, a square there that we're going to fill out. And we're going to figure out what number would have been perfect. As long as we add that same number over to both sides, we keep the equation balanced. Okay, so what we got here is we got to figure out this number here. Remember that the key of this special number is going to be the half of the middle number squared. Okay. So if I have this 7 here, I'm going to have to figure out what's going to be this perfect number that's going to go right here. So I'm going to take this middle number 7, cut it in half, and then square it. Okay. So that perfect number squared would be 12.25. We would have to make sure that that goes on both sides. Okay. If we ever have a number with an a in front, we're going to have to make sure we divide by a first. Okay, so notice here, this 18, if we take 18 cut in half, oh, I started writing it, is 9 and square it. That is not that. So what we're going to do first is we're going to move this over and leave it blank. So I'm going to put an x squared plus 18x plus blank equals 4 plus blank. So I move this 4 over and I'm adding a blank. Now, what would have been the best number here? 18 cut in half is 9. 9 squared is 81. If I want to add a 81 here, I need to make sure I have an 81 on both sides. So I'm going to put it there as well. Now, this is a problem that we can solve. And technically, we did not change the value of anything. We just rearranged and added the same thing on both sides. Okay, so we got a x plus 9. If I take that 18 cut in half, that's 9 squared is equal to 4 times 8, or 4 plus 8 is 85. So x plus 9 is equal to plus or minus the square root of 85. All right, 85, does that break down? That is 5 and 4, no. 85, 85 divided by 5 is 17. That's it. Okay. So our answer is x equals -9 plus or minus the square root of 85. And that's it, because we'd have 1 plus and 1 minus. All right. If we have a number in front, what we need to do is divide everything by that number. So we're going to divide everything by 4, even that, and even technically the 0. So we get x squared minus 3x minus 27 divided by 4. I'm going to put a decimal here. Could put a fraction, but we'll do 6.75. No, yeah, we'll do 6.7. No, let's keep it a fraction. Let's have some fun here today. So 27 over 4 is equal to 0. All right, so if I take this 3, cut it in half, and square it, that's a 9 over 4. That's not the same thing as 27 over 4. Okay, so I'm going to move this over and put some blanks in. So we get x squared minus 3x plus blank would equal a positive 27 over 4 plus blank. We've said right here the best number would have been a 9 over 4. So I'm going to add a 9 over 4 to both sides to keep it balanced. And so this would be x minus 3 over 2 squared is equal to 27 plus 9. That would be 36 over 4. Do we want to reduce that? Oh, well, that actually comes out really nice, right? So let's do that. Let's make this x minus 3 over 2 squared is equal to 36 divided by 4. Hey, morning. Is 9. Okay, cool. That's really awesome. So we get x minus 3 over 2 equals plus or minus the square root of 9. So x minus 3 over 2 is equal to plus or minus 3. So this is actually, even though that's a fraction and that's a real number, we can add fractions and real numbers together. So x would equal 3 over 2 plus 3, and x would equal 3 over 2 minus 3. So let's see, if I had 3 over 2, this would be the same thing as 6 over 2. So we get a 9 over 2, or 9 halves, or 4.5. If I subtract a 6 over 2, that'd be a negative 3 over 2, or negative 1.5. There are two solutions. So why don't you guys pause this video, see if you guys can get this next problem here. All right, this one should be fun. We got to divide everything by 6. And we would get, let's see, x squared minus, I'm going to reduce that fraction. 21 divided by 6 is 3.5 or 7/2. And plus 9 divided by 6 is a 3/2 equals 0. All right, 7/2 cut in half and squared be a 7/4, which would be a 49/16. Right? Double check on my calculator here. Yeah. That's not this, so we're going to move this over and put our blanks in. So we get x squared minus 7/2x plus blank equals negative 3/2 plus blank. That blank should have been great if this was a 49/16. All right. So this would be a x minus 7/4. If I cut a fraction in half, you just times the bottom number by 2 and then equals. Okay, I'm going to times this by 8 to make this 16. Times that by 8, that would be 24. 49 minus 24 is 25. Okay, that's good. 25/16. All right, so if we take the square root, we get x minus 7/4 equals plus or minus the square root of 25/16. The square root of a fraction, you just square root the top and square root the bottom. So that would be a 5/4, plus or minus. So this is a fraction, that's a fraction, both of over 4. So that's nice. We get an x equals a 7/4 plus 5/4. And we get an x equals 7/4 minus 5/4. So if we do that together, that would be a 12/4, which is 3. And then this one here, we'd get a 2/4, which is 1/2. So we get a 3 and a 1/2. That was our solutions. Did we get it right? Yay, good job. Okay. Once you guys pause this video, try this one on your own. Oh, I guess this is the last problem. I was trying to see the solutions here. Okay, last one. So we're going to divide everything by 3. I made an UG because I can see what's going to happen here. X squared minus 72 does divide by 3. That's 24. 465. That does not divide by 3, does it? Oh, it does. 155. All right, so if I take 24, cut in half, and square it, 12 squared is 144. That's 155. So I'm going to have to move this over and add some blanks. So we get x squared minus 24x. We got the x. Plus blank equals negative 155 plus blank. That perfect number would have been a 144. Okay, so we would have an x minus 12 squared is equal to 155, negative 155 plus 144 is a negative 11. Wow, this is going to be a lovely answer. This is probably why it's the last one here. Okay, now I say that. And if you didn't notice here, because we would take the square root of negative 11. So this one's really complex because we take the square root of negative means it's imaginary. And then radical 11 is just 11. So we get plus or minus I radical 11. So these problems I always think are not too bad if you feel comfortable with, representing complex numbers. And there ain't much we can do with that. So the only thing we can do is put the 12 over in front of it. The negative 12 moves over to a positive on the other side. And there's the answer. It is 12 plus or minus I radical 11. It is a complex imaginary radical. Ain't that fun? All right, guys, thank you for watching. You guys have a great rest of your day, and I will see you next time. We got one more section left this unit.